Hi, everyone. Today we're going to talk about LLM security and control with Hugging Face this week and YLabs. I'll give folks some time to trickle in, but in the meantime, a couple introductions to myself. I am Bernice Herman. I am a senior data scientist at YLabs. I do work with approximate statistics. That's what YLogs is all about. We'll talk about that. Real-time monitoring, data-centric AI, applied machine learning, and AI models. I'm also a research scientist at the University of Washington, although this work is unrelated to that. But worth noting that I'm really interested in evaluation metrics and monitoring and the sorts of stuff that I do here at YLabs. So happy to talk about that from the kind of academic context as well. Okay, so my role at YLabs, I focus pretty strongly on all of the statistics and machine learning work that happens at the company, as well as other data scientists. But my focus is really on the sorts of metrics that we select, the monitoring and anomaly detection algorithms. And there's a strong amount of math and statistics that goes behind YLogs and LangKit are open source products as well. Okay, so our agenda for today, we're going to do something a little bit differently. Normally, I finish the sessions with some code. We're going to start with some slides just on monitoring text data from LLMs to get kind of the basics for those who aren't as familiar with what we do at YLabs and how we do that monitoring. But then we're going to jump right into the code, and we're going to use Hugging Face to pull up a model and have some conversations. And then we're going to log that data, both with YLogs and LangKit. And after we do that, we're going to move into the control and security aspects of things. So we're going to talk about the control center that we've built and how that kind of works with any applications that you have that use AI data of any type. But in particular, we'll focus today on LLMs. And then finally, a demo of the platform of YLabs Secure. Okay, so let's go ahead and get started with monitoring AI and LLMs. And I'm curious for those who are inside of the workshop, please share kind of your experience with monitoring AI or monitoring LLMs in particular. Have you gotten to the point of deploying an LLM? If so, have you thought about monitoring and what have you discovered in your LLM? What sort of issues have you discovered when you're doing that monitoring or evaluation? Okay. While you're adding that to the chat, let's go forward and talk about this and our approach at YLabs for doing so. So we care very much about monitoring and observability for AI systems and control as well. But on the monitoring and observability side of things, this is a sort of diagram to help us understand how this works. So there are many, many types of data that you may have as a part of your system. And being able to handle many different types of data is really important to us, and a primary reason that we've become very data centric in our approach. And what I mean by that is a lot of the monitoring and tools that you have available at YLabs are really focused on the data itself. There's lots of things that you can get from the model. There's lots of tools to interact with the model. But what we care often about is the data that comes in your system, the data that comes out of your system, and often intermediate data through the kind of process of your system. So on the left, we can see a number of different ways that data might enter our environment here. So one would be model prediction data. After you've run a model, you will make predictions. You want to keep those outputs and so on. Model training data, right? So the data that you have that you've trained your models, you'll be wanting to work with that. And that can come in many different forms. So it can come from feature stores. It can come as kind of batch data or large sets of data all at once, or it can be streaming. You might have real-time data flowing into your system. For all of those, we have a privacy-preserving data agent. And so what this does is it captures metadata and statistics about your data that you likely has lots of private information, customer information, that sort of stuff. We actually don't need access to that private information in doing all of the observability and monitoring that we do in the future. But what we do need to do is capture some statistics, so distributions, information about missing data or nulls or summary statistics, data lifecycle events, this sort of information. And the way that this is done is all of that data is captured on your machine. So I should say all of that metadata, the statistical information, not the real data, is captured on your machine. And you can use that with our open source agent we call YLogs. And this is to log your data as you're kind of running your system. You can do many things with this. You may store them, use them to come back and do analysis if you found some issue to help locate where problems may be in your system or your data. Just keep historical stores of how your system has worked over time. But you can also send some of that data to the WhyLabs observability platform, where we will do things like aggregate statistics over time, store those statistics for you, and then do forecasting and monitoring and visualization and detection for you. And this is really helpful for a number of reasons. It's really unwieldy to deal with kind of lots of historical data. And finding issues in your system is really expensive and difficult. So we'll talk a little bit about that in the future. But then finally, you'll end up with things like reports and dashboards, alerts and notifications. So maybe a Slack notification when particular shifts have happened in your data or particular concerns about your model performance, triggers and workflows. So you could set up a workflow to automatically retrain your model if you have certain drift or things like this. Okay, well, so I mentioned that that aggregate statistics, and how is that done? Well, this is using our open source tool, YLogs. So you can go to GitHub, download this on your machine, kind of explore it. We'll be doing so in the code in just a little bit. But what is it? It's a sketch-based data profiling and telemetry tool. So the main focus of YLogs is to summarize data. And the question would be like, why summarize data? Data is very valuable. Why do we want a summary of it? And the large answer for this is really that, a large answer for this is really that doing analysis on the massive data that you may have in a production system, either over time or just in volume, is really difficult and really kind of expensive relative to some pretty standard insights that you might want to capture about your data. So instead, in practice, a lot of practitioners do some sort of summarization of one of a few different types. So one popular approach of the three we'll discuss today is random sampling. So we'll actually run this code in a little bit, but what you can do is take a sample, like a 5% sample that we see in the code here, of the rows of your data. So this is just, there's a 5% chance that any given row is selected. And what this can do is allow you to capture a smaller data set to do further analysis. There's lots of issues still with this. So imagine that you have a production system. It produces way too much data that you're not able to store and analyze if some issue comes up. It's just too expensive to run the sort of analysis you need to do to debug issues. What you might do is store 5% of that data. And then that's a little easier for your data scientists to work with and find insights about the running of your system. But one problem is that this 5% doesn't account for kind of tail events or rare occurrences, right? And these are the sorts of things that may be very detrimental to your system, right? So if you have some rare occurrence that happens, less than 1% at the time, maybe much less often than that, right? The likelihood that you have enough data to really understand this issue is pretty unlikely. So instead, we'd prefer to capture some statistics about the whole of the data as opposed to necessarily throwing away a large proportion of the data. Okay, so that's where we get to data profiling. So data profiling is the act of reviewing and analyzing data sets, often with an algorithm, to understand their structure and the information it contains. So things like collecting descriptive statistics, often things like different data structures or patterns in your data or data types. Sometimes data quality examinations and different results of that. These are all could be considered part of the data profiling process. And there are many open source tools for doing so. We'll, of course, talk about YLogs in more detail. So the way that you might approach data profiling is in a static way. It's kind of the way that occurs to us most often, which is that we'd like to, for example, grab the mean, grab the median, grab some basic statistics and information about our data set. And one place that we see this pretty often is actually with pandas. If we did pandas.describe for a data frame, we might get some things like exactly what I said, the mean, the standard deviation, that sort of stuff. But one step beyond that, or maybe a couple steps beyond that, is dynamic data profiling. So some issues with static data profiling, like you would get with a pandas.describe, is that, well, when I want to understand my data over time or across multiple machines, I can't necessarily merge those together. Another issue is that if we only capture profiling information and we throw the other data away, without being much smarter about how we do that collection, we may be really stuck. We've had to kind of predetermine all of the metrics that we care about, and we can't go back and kind of do further analysis or readjust or recombine data when we want to. Well, that's where dynamic sketch-based data profiling comes in. So we can do this with y.log, and we'll see this in a little bit. But this is still doing that sort of data profiling, capturing statistics about our data, but we're actually capturing much more detailed distributions about our data and much more dynamic data structures for describing this data in a way that we can get, for example, error bars, we can get distributional information, we can combine data from different times together and get the appropriate error bars and distributions for the combined data. And it allows us to do things like go back and calculate metrics that we didn't calculate in the past when we first saw the data. But we can now calculate with this kind of complex description of the data that's passed through. Okay, so I mentioned some of these benefits, why they're great. They're kind of combination between data profiling in general, this fast access to key metrics. So if I've collected a data profile with things like the mean and things like the number of missing values and which missing values those were, or the number of outliers and which outliers those were, the cardinality, how many unique values there are. This makes it really easy to capture kind of the key metrics that you'd start your analysis with and often can resolve your analysis with. And they're right there accessible to you. No need for a large amount of computation or memory to get there. I discussed the high flexibility that you get from sketch-based profiling versus static profiling. Another note is that they're very low memory and storage size. So there's a number of metrics and there's some data structures involved, but it's a pretty small storage size that doesn't scale or grow, or sorry, it does scale. It doesn't grow the amount of memory you need based off of the number of rows of data. So if you had millions of rows, this works really, really well for you. And in many production environments, that's what you're going to be looking at is many, many rows. This mergeability I talked about, and built on peer-reviewed algorithms, right? So there's a large body of research focused specifically on this idea of data profiling so that we can have the right error bars, a better understanding of the bounds of those errors that we're estimating, and more accurate descriptions of the data that passes through. The cons are that some pre-selection of metrics can be really helpful still. This is the case for data profiling in general. You're not as restricted as static data profiles, but it's still helpful. And so we spend a lot of work, myself very much included, at WhyLabs, coming up with multiple metrics that help to describe your data in a way that allows you to investigate issues quickly and understand your system in the context of like a AI system or machine learning model or LLM. And then finally, there's some underlying algorithmic complexity. And that's kind of our job as maintainers of the YLogs package to make sure that these sorts of data profiling techniques work well for our data and in many different use cases. Yes, this is something that we do. So now that we've talked about YLogs and using data profiling with sketches, how do we translate these techniques to complex data and LLM data? So LangKit is our second open source tool that I'll talk about today. And this is all focused on text and LLM specific tools, so language, and what are the metrics that we need to build on top of text and LLM specifically to understand which issues may be going on and find issues with security or data quality. So just some thoughts about text-specific metrics and concerns. So for example, this is a sentence from Wikipedia or something like this. And if you had let's say an answer from a chat bot or some system that you're using in your business, you would have, some text that describes what the outputs are. So this sentence right here. But it can be really difficult to take this text and come up with an insight of, this is why my system is gone wrong. I know that this row of data didn't really give a great result. But there's lots of text-specific metrics and ways we can reason about text that will help. So what we see in the picture is a specific one. So this idea of named entity recognition, this idea of looking at the text and finding kind of specific dates, people, organizations, that sort of thing. So why is this helpful? Well, this might tell us quite a bit about how our LLM is responding to users. So if our users are asking questions, let's say our application is meant to be used kind of generally, not to ask facts, but to ask, ponderings about life or something like this. It might be quite concerning to see that the bulk of our responses or any particular response has this amount of kind of named entities in it, right? These are specific dates, specific organizations and people, and we're now starting to kind of get in the world of facts. And, for lots of LLMs, performing well on this sort of like factual knowledge can be really difficult or dependent on how related to the initial training data set these questions or facts are. And so this is something to track. This is something to note. And things like there are many, many other metrics that that kind of bring these same issues, raise these same issues. So here's another challenge, one that we think about quite a bit for LLMs, and that's hallucinations. So for those of you who haven't seen a hallucination before, first, I guess I'll say that this is a particular chat with ChatGPT, and this reporter asked a question to summarize this article and gave a URL to what seems to be a New York Times article. Well, the interesting thing about this request is that that URL there does not point to a real web page. It doesn't exist. It hadn't existed in the past. But the LLM does produce a response that seems reasonable if you didn't know any better, right? And the answer is that this LLM didn't go, we didn't have a tool or function that allows our system to go look at a URL and scrape the data from the actual URL. But the LLM, seeing many data sets with URLs before, can kind of make up some things here. So the fact that this URL points to the New York Times and it has words like technology, ChatGPT, prompts, content filters, that's enough to kind of hallucinate a full paragraph response about what's happening in this article. And that's the sort of stuff that we care a lot about, right? Like, so if we have a system in production and it's able to do things like this, we need to start thinking quite cleverly about what metrics can we collect about the text that's running in and out of our system, so that we can detect when this is happening. So let's maybe back up a little bit and talk about LLMs in general. So for LLMs, often what we see are prompts, so text coming in that users have written. And I think in many business applications, people forget that those prompts aren't always passed in kind of raw as is. So maybe in the context of a chatbot or something like this may happen. But often the creator of the application will take some user information, sometimes not even real-time kind of prompts, just a collection of statistics or user data, something like this, and create a prompt from a template to pass into an LLM. So either way, whether that's created kind of here on this bubble of the left of some other process or passed in directly from the user, we generate a prompt. And that prompt is passed into the LLM, which many sources have. We're going to focus on one from Hugging Face today, created by Microsoft. And the response to this can be many things. So we're going to focus today on text responses. But this is another example of where this complexity might come in. Another thing to consider as far as complexity is a chat. So a chat often has many prompts and responses and conversation back and forth. So some much more complexity than our maybe standard data frame that we think about when we think of tabular data with just numbers and categories. Okay, so we need to translate these prompts and responses to useful forms. So we talked about metrics, and this is some ideas about the sorts of questions that we want to ask. So we want to ask questions about the quality of these of the prompts and responses coming in, the sentiment. So is it positive? Is it negative? Is there some sort of way of speaking, right, that is worth noting that might indicate that the user experience isn't as we'd want for our users? Security. So this is a huge one. Things like jailbreaks. So if you're not familiar with jailbreaks, these are attempts to get the LLM to give a response that was not intended. So for example, many LLMs and applications built on LLMs very intentionally don't want to, say things that are toxic or say things, for example, give medical or legal advice, right? You don't want to be liable for any medical or legal advice that your system provides to users. So what we might want to do is not only track whether or not medical or legal advice was given, but also track are users giving the sorts of prompts to try to get around that. And there's some really clever ways of trying to jailbreak a system. And so keeping on top of how often your users are doing this sort of thing is very important, as well as things like leaking sensitive information. How many social security numbers or things like that are being passed in? This can be a very innocent thing that happens with a user who passes in their password. Maybe it's copy pasted, or passes in some financial information in their conversations because they don't quite understand where the data might go. And then finally, governance, right? So we have all sorts of policies internally, and maybe depending on your domain, from other bodies telling us, that we need to track information about who the LLM, who the text from the LLM is reaching, what that text contains, that sort of thing. And metrics inside of LangKit will help us to kind of uncover these sorts of things. Okay, so what are some of the example metrics for text specifically in LangKit? So things like text quality can be explored with readability scores or complexity scores, right? So if you have a system that is meant to give academic texts or academic like prose, you'd expect to see a different sort of complexity of text and the kind of vocabulary used from a system that's meant to address children, right? Or so on. Text relevance. So a big one to understand our system and whether or not our LLM's even working well for us is similarity between the prompt and the response, right? So if the prompt that you have given is about a particular topic, maybe about shoes or fashion, we'd like to see that the response is somewhat about shoes or fashion, right? And it's not that every single time these things have to align perfectly, um, but this is a really good indicator of whether or not our LLM is working as we expect. Same for similarity against user-defined themes. So if you have an application that is about legal situations, then we would like to see that our similarity to legal themes is pretty high. In many other applications, we'd like to see that that similarity to legal themes is quite low. Okay. And then next, security and privacy. So we already talked about jailbreaks, and we talked a little bit about these patterns, so things like social security numbers or phone numbers or so on. Refusals is another concept that I think is worthwhile knowing if you don't. So refusals are about how many times does the LLM give a response, like something like, "I'm sorry, I can't give you an answer right now." Right? So why is that important? That is often a poor user experience for the user of your application. Excuse me. So, so you might really want to know, how often is this happening? What can I do? Maybe I need to change my prompt templates and things like this to reduce that. Maybe I need to have some sort of guardrails, and we'll talk about that later. But to capture these instances of a refusal and give a different response or redirect the user before they get that sort of negative response. And then other things that are important, sentiment analysis and toxicity analysis, right? So toxic language in the response from your LLM is normally a pretty bad thing. Even understanding the toxicity going into your LLM from the user is really important. Okay, and then after LangKit, you can pass that again once you've used YLogs to summarize all of this information for your text. You can pass this into the observability platform where we see many of these trends and insights that you wouldn't have otherwise. Okay, so let's go ahead and head over to the code section. So I'm going to open up this link here to our Colab notebook. And I think just really quickly, make sure that it's sharing. Yes, cool. Okay, so I'm going to, just so that we're all on the same page here, I'm going to disconnect and we can be on the same page. For those of you who are following along, go to File and then create a copy either in Drive or in GitHub. The reason for this is that I have a copy here. It's read-only, but it's really helpful to be able to save and edit and add, your own prompts and things like this. So if you want to do more than just run the files here, just go ahead and save a copy if you're signed into a Google account. So let me reconnect here. So what we're going to do is we're going to start a YLabs account. But before we do so, I just want to get the install started. So I'm going to click on this first cell here. And you can either click this play button right here or hit Control Enter. So I'll click the play button now, and I'll try to remember to remind you of Control Enter if you're not as familiar with the notebook environment. Okay, so as that runs, we're going to go ahead and click on this link here to start your free YLabs account. So the reason we're going to use this account is to be able to upload our own data and see these kind of further insights that you can have. It's free to get started. So just click the Get Started for Free button right here. And if you pass in either your email address or sign in with Google or LinkedIn or GitHub, you can go ahead and get started. It's really fast. You'll just get an email with an activation link and click that, and then you'll be in. I'll give folks a little bit of time. I have already logged in, or I already have an account, of course, so I will go ahead and log in. Okay, So when you get here, you're going to have probably an empty environment here because you don't have any data yet. But I'm going to go ahead and redirect you right now to the global demo organization. So as people get caught up, we'll come back to this in a little bit after we've run the code and gotten some data. But if you want to explore as we're kind of getting caught up, go to the global demo org, and there you can find a number of example projects, and we'll look at the LLM secure later in this demo, but go ahead and check out any of them, including that one if you'd like. Okay, so now we're going to go check in on our data download here. Mine is still running. So I'm downloading a set of pretty heavy things. So largely transformers, and we're still working on evaluate here in Hugging Face. But LangKit and YLogs also have an install. Okay, so we're finished here. I'm just going to clear this just so we don't have to see it. I guess I can just hide it. Okay, so let's get started with importing YLogs as Y. Okay, and it's very easy to get set up and started. Let's go ahead and actually do a step here. So let's go back to the platform here, and we're going to go to our settings. And if you are just getting set up for the first time, you need to go and get an access token. So actually, let me go here and jump into my own organization here. So this is the one that I have 2 models on here. I'm going to go settings, access tokens, and you can make an access token here by just putting in a name for your token and hitting enter. So I'll do one here, demo. You don't have to put an expiration date. I'm going to put one just so I can keep things cleaned up here. 3/20/24. Okay, and creating that access token. So what we see here is a code here that we can download or copy. Make sure to save this because you won't be able to see it again, as pretty common for these API keys. And we'll reference this organization when we use it. It's also contained in the token now, so no worries there. Okay, so we're going to use this in our setup. So what can we do here? We can now go back to our code and run y.init. And when we run y.init, it asks us, how do we want to access? So if you've set up your YLabs account, which I highly suggest, then you're going to go ahead and press 1. And it's going to ask you to enter your YLabs API key. And you can paste what we just copied into this here. And then we can optionally add a default dataset ID to upload to. I'm going to suggest that we do that. And so the way that we can do that is going to look at our projects here. So you probably don't have a resource here, but if you'd like to create a resource, you can click on this, and it allows you to create a model here. I'm going to actually, so go ahead and give it a model name. And we want to give it a resource type of large language model. I'm going to actually delete one here just so that I have some space. But I'm going to go ahead and call this Hugging Face Demo LLM. Just making one and adding that model. So now I have model number 35. And we will pass that in as our default dataset ID. Yours will probably be a different number. Okay, so once that's been done successfully, you'll see this green check mark here with some information about your session. Okay, great. Okay, so let's get started with Hugging Face. So we've done all of the downloading, so we should be ready to go. PyTorch is included in Colab. If you're not in the Colab environment, you will have to also pip install PyTorch, which can be a little bit specific to the hardware that you're using. Okay, and operating system. Okay, so we're going to import transformers, we're going to import torch, and then pandas. So let's run this. Okay. And so what are we doing today? So we want to use an LLM that we have access to in Hugging Face. And there are several. The one that we're going to use today is the Diallo GPT model, the medium-sized one. And this isn't the best, like this is a great model for many different purposes. Certainly OpenAI, GPT-4 or 4.0 these days. These have other benefits, but this model is really great for lots of applications and open source and free to use. Really excited to use the Microsoft one here. There are many others on Hugging Face as well. So Hugging Face has Llama 2 and the newer Llama 3. There's a little bit of kind of work to get access to that model. So you'll have to sign some forms and wait until you get some access. But there are many, many great models on Hugging Face. Okay, so I ran this cell right here, and a couple of things. So I have not set up Hugging Face Hub, which is kind of a place where we can store models and have an account and things like this. So this warning is just telling me that I'm not set up for that, but that's totally okay. So what we've done is we've done two things. We've downloaded from the Transformers package, which is a Hugging Face provided package that that allows us to use many of the transformer models that they have available. I'm going to download two things. One is a tokenizer, and we'll see how that works if you're not familiar, and then the model itself for Diallo GPT. Okay. So the process of downloading or for using the LLM in this case, this response is actually going to be different. So let's clear that. So first we're going to encode the input for a prompt. So in our case, let's just assume that we're passing the user prompt along. And so we're going to ask for the user prompt here. And I might say, what is happiness? Okay, so we've asked a prompt here, and the output to this is an encoded input. And I forgot to do a little thing here, but let me just show you what's in this. Coded input. What you see is actually the tokenizer, which is what we use here, has translated our sentence here into several tokens. So these correspond to different tokens here. So what is probably this one is happiness, maybe a combination of these, and sometimes the question mark or end of sentence are other tokens. Okay, so now that we have this tokenized input, which is what we need to be able to use this particular model, we're going to pass in that tokenized input, this encoded input. We're going to give a maximum length of the response. The reason we want to do that is we don't want the model to turn too long, and we have to give some maximum length. We're going to give a fairly high one, depending on your context or problem, but 1,000 is pretty good for our case here. And then we're going to pass a token ID for the padding, so the very end, which is likely this one here. Okay, so I'm going to hit enter here, and it's going to take a little bit of time, right? Because this is our LLM. It's going to give a response. And so this response actually contains both the input and the output. That's just how this model works here. So we can see that this, this is the same as what we saw above. And then this is likely the output. So we can go ahead and check that. We can take our tokenizer and we can decode what we got as an output, but we're going to focus on just the bits that are after the input, the size of the input. So that's exactly what we're doing here. We're going to skip the special tokens and decoding, and we'll see what the response is. Of course, it's baby, don't hurt me. It actually gives different responses every time. Oh yeah, I thought I asked what's happiness, not what's love. Very interesting. It still says baby, don't hurt me. Okay, so cool. So we just used our LLM. This is awesome. And this is completely open source. And it's worth exploring what this LLM gives us responses because it's really going to depend on application whether or not these are the responses that will work well for your use case. Okay, but let's go forward and let's think about how to log this data and just in general, how we might use this other than a kind of one-time run of the data. So the first thing we're going to do, it's not necessary to do it this way, but just to make things easier on us, we're going to start storing all of our chat history just so that we have it and we can kind of build a pile of it before we log and think about it further. So I'm just going to create a data frame under the global chat history here with our prompts and our responses. And this is basically just the code that we've had before in these multiple cells. But I'm going to allow us to kind of do more of a chat back and forth and then quit using Q if we want. So no need to kind of analyze this. The thing to note right now is just that it's roughly the same code that's happened, but it's just going to happen in a loop with some number of max iterations. Okay, let's hit enter. Okay, so let's go ahead and clear this. Let's go ahead and run our chat here, and we can ask any question we'd like. So maybe not what is happiness, because they just go into a musical joke. But maybe we ask questions like, hello, is this thing on? Uh-oh, what do we have here? Chat history IDs. Oh, very weird. Okay, that's equals chat history IDs. So I actually think this is a formatting error that I made. So let's go ahead and just clear this up. I'm going to make this all one line and try this again. Oh no, I'm still having an issue. Oh, I apologize. Okay, what's going on? Chat history IDs. It is referenced before assignment. That is fair. I think that's okay. What we can do instead is we can just pass in our new user IDs every time. So this little bit of code that I wanted to keep a chat history for, unrelated to the demo, that seems to not be working here. So let's just run this like this. And we can still ask the same sort of questions. How are you doing? And now we're getting some responses. So I'm doing well, thanks. We might ask, what sort of AI model are you? I'm a human. Well, I don't quite believe you, but that's okay. Let's go ahead and quit. Okay, cool. So we're going to continue to collect this chat history, but let's go ahead forward. So how did we get started with YLogs here? Well, let's imagine that this chat history, instead of being something that we're just playing with right now, is actually some data about our ongoing process. And you don't have to store this necessarily. We can certainly log data as each individual interaction with the model comes in. But we just want to look at it now. So let's look at chat history here. So let's think about the different ways that I mentioned summarizing data. So we could, first way would be take our chat history and take some proportion of the data. Of course, our chat history is really, really short. So if we had some more time to fill this out, maybe we get many more. Maybe we'll just go ahead and take something like 0.75 just to see some data, right? So we get some sort of sample here. But imagine in a more realistic percentage, right, we'll have much less compared to the data that we actually have to describe. Okay, the next is simple data profiling. So we do our chat history.describe using pandas, and we get some very, very, very basic statistics about our data, right? We understand the counts, we understand the number of unique values, we understand the most frequent value, which is really just the first one in our list because they're all unique. And then we understand the frequency, so one of each of the most frequent prompt and response. Okay, so now we finally can get to the point of using YLogs here. So we've explained all the other ones. Let's go ahead and use YLogs. And it's also very, very simple. So if we wanted to do our chat history here, we can just pass in our chat history pandas data frame to YLogs. So y.log, we pass this in. And if you've set this up with your platform account, you now see here a link. And this link allows us to explore our data here. Okay. And the thing to note is that before we have text-related metrics, we actually don't see a ton of things. There's so many, many things that are helpful, similar to that sort of static data profile that we have. Information about, but some more information. So things like data type, counts, estimated mean and standard deviation doesn't really matter as much for text. No nulls, and total count. And there's more information to be had there. But what we really want is some of this text-specific information that we don't have. And so this is where LangKit comes in. So let's scroll down here and let's run this first line here. So what I'm doing is I'm importing the light metrics module from LangKit. And light metrics is a faster one to allow people to use this. You can also use LLM metrics. I'll leave this at light metrics here. But this is a number of different metrics or combination subset of the possible metrics that you have. This is also a subset. This is not all of the metrics that we have, but a set of metrics that you may want to run on your data. And what we can do is once we've set up our module or chosen our module, we can also add custom metrics or combine modules. We need to initialize this module and set it to a schema variable. So we'll use the schema variable when we log data. So let's go ahead and run that. We'll initialize the light metrics. And now let's do the same thing. Let's do y.log. We're going to pass in our chat history, but we're going to set our schema to LLM schema. That would be enough. But if we did this without giving it a name, this is just going to be considered as production data, kind of like the last bit was. If we give it a name, this will be held out as kind of reference data. So this is the more standard way you're going to start, for example, with your training data or some example data that you're playing around with. So let's go ahead and log this. Again, we only have 2 rows, just because I wasn't creative enough in my chats, but that's okay. So maybe this took a little bit of time. So let's refresh here. There we go. So now we see, instead of just the merged data that we had here, so this was our prompt and response from earlier, we want to instead look at our chat history LLM metrics that we just saved. And so here we see much more information because this is what LangKit did. It calculated all of these different metrics for us on our data. So things like our reading level, other scores for reading, so a readability index, character counts, difficult words included in the response, patterns such as social security numbers, things like this, letters, monosyllabic words, polysyllabic words, so whether or not there's more syllables, kind of the complexity of the words, the number of sentences, and then more advanced things like, actually, we're using the very simple one. So this is the lightest weight one, but still much more interesting metrics. There's even more interesting metrics if you use the LLM metrics tool. We'd see things like has hallucination similarity, that sort of stuff. Okay, so let's go ahead and take a look here at other views of this data. So we can do a couple of things. We might want to go ahead and go to dashboards. And actually, I'm going to go ahead and really quickly download LLM metrics just to have a little more fun. we're going to download some more interesting data. But let's go ahead and go forward. So this is kind of the basics of Hugging Face and LangKit that we ran through. And let's talk about the control side of things. So far, we've really focused on the observability and monitoring side of things. But recently, we've announced our WhyLabs AI control platform. And observability is only one side of this. So this has kind of the monitoring for LLMs, for model performance, for data quality, drift, other features in the platform that I didn't get really a chance to show, things like this, alerts. But we also have many other options on the security side of things. And so one way we think about this is tracing. So I'll show you a slide about that in a little bit. But another is real-time guardrails of your system related to some of the metrics that LangKit produces. So things like misuse or poor experience or so on and so forth. Okay, so again, how did we approach observability? Well, there's lots of tools inside of YLogs that and the platform about evaluation, monitoring, observability. But now let's think about real-time control. So the things that we're going to think about now are tracing. So how did a particular interaction transpire? And guardrails. So when to and how to impact a particular ongoing transaction. So what you might have noticed is that we've moved from the world of summaries to the world of looking at specific interactions, like a single row of data, and often in real time. Like, so especially for guardrails, I want to know answers to questions before we even finished. So traces looks a little bit like this. In addition to seeing kind of summary data, which can be really helpful for understanding a production system, you might determine that with some sort of heuristics or just samples or whatever settings that you have, that you'd like to store a trace of particular instances running of your LLM model. So this is done very, very easily using YLabs and open LLM telemetry, where you can now collect this trace information for a particular interaction. And again, we're very privacy focused. So your interaction doesn't have to include the raw data. Instead, it includes these sorts of metrics that we talked about. So that you can capture from LangKit, or you can capture from YLabs Secure that has more metrics. And yes. Okay, so let's think about a single interaction. So this is just one example from a paper that I pulled about how this interaction might work. So a human user interacts with a user interface, and through this interaction generates a prompt of some sort. This prompt might get broken down and have templates and different work on this prompt to eventually generate tasks. And those tasks are sent to an agent, which sends prompts to our LLM and responses back from that LLM. That agent handles responses back from that LLM. I won't go into too much detail about the other bits of this. So our agent might send prompts to the LLM. It may work with different tools. So we talked about this, that example of a hallucination. If you're writing an LLM-powered tool, maybe you actually want to use some function to go to a website and scrape the content of a website, something like this. These are all tools, calculators, that sort of thing. But either way, our agent does a lot of this work of doing the coordination of the LLM and the different tasks that were broken down. And this gets passed back as a result and one or multiple responses. Okay, but there are many places where you may want to redirect the workflow path of a single transaction. So for example, maybe you have a prompt that the user's given that just from the prompt alone, you can tell we don't need to finish this interaction, right? It's maybe, for example, something really inappropriate. So maybe we flag this response or this prompt We might let the interaction continue, but we just want to flag so that when we look at our alerts, we can see, okay, let's trace this and we can understand better what this prompt was. Other examples. So for example, let's say the LLM gives back a refusal. There was a prompt that was requested and the LLM says, sorry, I can't give you an answer to that. Well, we may want to block on receiving a refusal so that we can prevent the user getting back kind of this form response from the LLM. And then finally, we may want to alter prompts depending on what's in the prompt itself. So a common example is data leakage. So if we have a prompt that has a name or email address in it, we may want to actually remove the name or email address and replace it with kind of a common token or indicator so that the LLM doesn't have to see the private sensitive information, but you can still continue on with the process. So this is an example of altering something in our process. Okay, so the question is, well, maybe past this. I think this was meant to be earlier, but we can use those same LangKit metrics on these individual interactions instead of summaries. So while earlier we were kind of doing many things in one combination, we were calculating individual metrics, but then we were summarizing those metrics with YLogs and passing them along. LangKit has the tools to be able to calculate these individual metrics for each row of data. And this is the information that can be really helpful for us to do this sort of blocking and guardrailing. Okay, so finally, I want to finish here with a quick demo of the WhyLabs secure side of things. So I'm going to go back to our web page here, and I'm going to switch over to our project dashboard, where I'm going to encourage you all to go to the global demo organization with me, and we will see our demo LLM secure. So if we click on this, we see a very familiar page. This is the summary page for each project, and we can look at a number of things. So we can tell already that this is an hourly model, and it has some performance metrics in it, which is great. We have some security metrics in it as well. So let's go ahead and we'll actually start with our telemetry explorer because we haven't seen this yet. So I want to just make sure that I'm looking at the right data here. So clicking on this, these states here for some data that's been uploaded in the past. And we see many metrics related to the sorts of things that you can see when you use the WhyLabs secure tool. So they're related to the LangKit metrics, but the LangKit metrics are open source. These have much more detailed values in them. So we have things like PII, so credit card information, email, bank numbers, that sort of stuff that we want to make sure to not include in our data before we pass it on to the LLMs. We have things like similarity to prompt injections or jailbreaks, those kind of bad things that we see in the prompt that indicate that the user may be doing something malicious. We also have things like truthfulness. So how truthful is this data? Things like misuse, bad actors, many other things in this data set. So what can we see here? So we see all of the sorts of metrics that we're used to seeing in the observe side of things. We're still on the observe side of things, but let's go over and look at LLM secure side of things. So on the LLM secure side of things, what we're doing is we're seeing the individual interactions, the policy violations from those individual interactions. So of this about 78 interactions, we see that 25 of them had some sort of policy violation. And we can see over time kind of the proportion and click on them to see some more context here. So let's view the related traces. So for this particular day, we can now see the traces that were stored for that day. And we see information like the application ID that we set, different violations that may have happened. So the tags with refusals, so these are both refusals, latency, token usage, version, all of this great stuff. If I click on one of these, I see something similar to what we saw on the slide here. we have a trace and lots of different information about what's happening in that trace. So we can click on different spans and see different information in that as well. And inside of our response here, we see lots of attributes about the response. So things like, again, PII information, toxicity score, so on and so forth. Cool. And then finally, and for our demo, I know we're right at time here, we can set policies on these different violations. So right now they're not set in this demo, but if we were to turn these on, we can, for example, see that we'd like to block any situations where there's a bad actor, and it will have a certain level of sensitivity. So high sensitivity would mean that we are trying to capture more of this. We have high sensitivity to bad actors, low sensitivity being the opposite. And then lots of other different policies that are important and helpful to set. So for example, for misuse, we can now separate things. Maybe for our application, we really care about medical topics. And so we want to make sure to flag any responses or prompts related to medical topics. And other examples, so like customer experience things, we can, for example, observe those. We'd like to see those inside of our application as flagged. We'd like to see those inside of our application, but we don't want to necessarily flag them or give any alerts. Cool. And there's many more. I will do a workshop going into detail on these different policies, but this is just meant to be a high-level demo. And with that, I will finish off by thanking you and pointing you to our Slack group if you have any questions, or you can reach out to me directly at Bernease at WhyLabs.ai, or on social media, largely at Bernease, so Twitter or X, LinkedIn, that sort of thing. And I see a question here. The question is, can some end users choose to turn off monitoring of their prompts, either through settings or at runtime? So end users, I assume you mean end users of YLabs. And the answer to that is yes, you can absolutely turn off monitoring as the person who is controlling the application and with YLabs. Yes, absolutely. Through settings or at runtime. So if you're talking specifically about these secure tools, then you can do this at runtime. For the observe tools and kind of the more passive way of monitoring, often what's happening is you are passing, well, I guess you can still do this at runtime. You'll just have to have the logic yourself to do that, right? So you're either passing along that data and you can remove the data you don't want to monitor, or have some sort of control flow for determining that. All right, cool. Thank you.